Saxon Algebra 1, lesson 115. I hope you guys feel really smart. We have just ripped through this book. Our topic today is called linear inequalities. Sounds hard. Give me a chance to explain. Most students end up thinking these are kind of easy and cool. We're also going to build on these a lot next year. So, you know, spoilers. It's this kind of graphing, the graphing that lies on the Cartesian coordinate system. And we have done a fair amount of work this year of drawing lines, right? We've talked about lines. We know they have equations that look something like this, right? Where we have a slope and we have a y-intercept. I forgot to write the y. I'll squeeze it in there. Okay, and we know how to graph those, and we know how to derive these, and we know how to talk about parallel lines and how they connect to them, blah, 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 right? Well, here's something that you may not have ever thought about, but will probably agree with me. When we draw a line, pretend it's perfect. Somebody's making noise upstairs and Gracie's she's on the case. Good girl, Grace. Good dog. Go look. Go see what's happening. Go see. Go see. Good girl. Ever alert, my dog is. Okay, so what a line does is it essentially divides the whole plane into three regions. There are the points that lie on the line, right? Those are the points we usually talk about. But there are also all these points up here. And we say that they lie above the line. Good girl. Is everything better now? She's back. Okay, so we can talk about this whole region and all the points up there. She's come over for a little petting. All these points we say lie above the line. These points are below the line, and I'm going to polka dot these just to make sure you can see the difference, right? These are all the points that lie below the line. And then, of course, I could just do that all day. These are the points that lie on the line. The ones that are right there. Okay, so three different regions, and sometimes we want to talk about these other regions besides just the line itself, and that's where we use linear inequalities. The way that we do that is instead of using an equal sign, we use an inequality there. We can use a greater than, we can use a less than, and we can use the equal sign. Oops, this way. Now the cat wants in. Sorry, you guys, hang on just a second. Pause, daydream. Good girl, Gracie, you stay right there. Hang on, kitten, I'm coming. Good girl. Okay, I'm back. Gracie sat next to my chair the whole time and stared at the book, so you know, you were being watched. Okay, so this set of inequalities allows us to describe the three different sections in different combinations, okay? So we're going to take a look at how exactly you would graph something like that. So here's the first example. 115.1. Graph the inequality y is greater than minus x plus 2. So I'm going to write the steps over here. So the first thing you do, you graph as if It was a line, okay? And I'm gonna put a star by the word graph, okay? And I'll come back to that. So we're gonna ignore the fact that this is an inequality, right? We're just gonna pretend in our mind's eye that's an equal sign. And we'll just graph this the way that we normally would. So here's my Cartesian coordinate system. I'll fill in the numbers that I need as I go. The slope, wait, there's no slope there. Oh yeah, there is, we can draw it in. It's a -1/1, right? So we'll come back to that. We always start graphing with the y-intercept. We go to +2, right there. And then this tells us to go down 1 and 1 to the right, right? The numerator tells us whether to go up or down, depending on the sign. The bottom is always to the right. So we're going to start at the 2 and we're going to go down 1 and over 1. Our second point is there. Now, so we graph it in our mind's eye. Well, let's do this. Let's graph the 2 points. That'll help make that clearer, right? We just graph the 2 points. Now, we have to decide dash. Dash or solid. Okay, if we're graphing just a straight inequality, we want to use a dashed line. And if we're using the equal sign in conjunction with the inequality, then we use a solid line. Okay, that helps us describe whether we want this line to be included in the solution or not. In this case, we don't have an equal sign. That means the line is not included in the solution. We only want the region either above or below. We haven't figured that out yet. But we do not want to include the line in the solution, right? This is the third region, right? 1 is above the line, 2 is below the line, and 3 is on the line. In these two scenarios, we're saying we don't want the line as part of the solution. So I see that in my example here, I want to have a dashed line. I don't want a solid line. So I fill it in. Pretend it's perfect. Oh, it's not horrible. Okay. The last step use a test point to shade. That doesn't make any sense yet. Let me explain. We later will get pretty good at guessing which way to go. But as of right now, we don't know if this inequality sign means that we should take the values up here or the values down here, right? We don't know which of these two regions will have the solutions for this inequality. So what we're gonna do is we're gonna just pick a random point on one side of the line or the other, and we're gonna use the numbers of that point to plug in for X and Y here and see if it makes sense. If the numbers work, if it turns out to be a true statement, then we will know that the point that we picked is in the part of the graph that is the solution, right? The test point will tell us whether or not this is the right side for the solution. If the test point numbers make sense, then yes, it is. If the test point numbers don't make sense, if we come up with a statement that's false, then we know, oh, the solution lies on the other side. All right, and I think in this example, well, never mind, that's spoilers. You can use any point you want for a test point, any point in infinity for a test point, and that will tell you all you need to know. But the easiest test point to use in most cases is the origin. So when I say test point, I'm leaving it open for you to choose, but I like to always use the origin unless, and I'll give you the caveat right now, unless the line goes right through the origin, and then it's not going to help us because the point is on the line and not in one of the regions. So pick easy numbers, whatever you choose to do. So now we're going to do the test. So I'm going to write that right here, test. Haha. So we're going to use this equation and this pair of points. So 0 is greater than minus 0 plus 2. It's another reason I like to choose a point that has the same number for x and y, because that way, even if you get confused or sloppy, you can't screw up plugging the wrong number in for the x and the y, right? They're both a 0, it's easy. Okay, let's see if this is true. 0 is greater than, let's see, minus 0 is just 0. 0 plus 2 is 2. Is 0 greater than 2? No, that's false. So that tells us that our test point, which happens to be 0, 0, is not part of the solution. So that means we go to the other side. So what we're saying is that the solution to this inequality is all the points that are on that side of the line. Doesn't include the line. That's why we put the dash there. It's our way of saying everything but this line. But it's this side that the points of solution all fall within, okay? Yay, that's the right answer. Kind of weird, not that hard. There's 3 more. Okay, let's keep going. These lessons are getting a little bit longer here at the end of the book, which is it's good practice for us because next year our lessons are a little bit longer. Okay. Y is less than or equal to 2x minus 1. Okay, so the first thing we do is we graph the first 2 points. All right, here's our y-intercept minus 1. That's right there, so there's our point. And then this is 2. I need a fraction in order to figure out the slope, so I can put it over 1. It's the rise over the run, 1, 2, 1. Okay, so there are our 2 points, yeah? Now we decide, step 2, if it's dotted or dashed. I always say dotted or dashed, but it's really dashed or solid. So if I say dotted or dashed, just roll your eyes for me at home, okay? But I'll tell you what, I will always do it I'll always draw it correctly. I just say it wrong. This equal sign tells us it's a solid line. We don't need to use the dashes. So I just draw a line as usual because what we're saying is that the line itself is part of the solution. So we can draw it solid. Okay, so that's step 2. Step 3 is pick a point, test, and see which side the solution falls on. Now, our origin is still safe because the line doesn't go right through the origin. So I'm going to go ahead and use my origin. Remember, you don't have to use the origin. You can pick any point and it will tell you whether or not that point is included in the solution. So if I chose, what would this be? Negative 5, 5, say something like that. That would tell me about this region. Well, it would tell me about this one too, because if it ended up being false, that would tell me that this side was the solution. So your test can be any point. The origin is just easy. I'm going over that a lot because that often confuses students and I can't see the little light bulb going on in your eyes. Okay, so now we're gonna see if it works. 0 is less than, I'm plugging 0, 0 in for x and y here. And this is where it comes out really nicely because whenever we multiply the slope by 0, it just goes away. Okay, and this says, now I simplify, 2 times 0 is 0, minus 1. This says 0 is less than or equal to minus 1. That is false. Interesting. In both of our tests, the test has failed, which is fine because it tells us all we need to know. This tells us that the origin is not part of the solution. And it's the origin because that's what we used for our test point. Our test point failed, so the solution lies this way. You'll see that in the book, in John's pictures, he colors this in solid. It's a solid gray. Well, that's cool, and if you want to sit and color and fill that all in, that's fine. I just use lines to indicate the region that is the solution, and this is the correct answer. Yay. Y is greater than minus 2. Whoa. We look at this and we go, what in the world? That's not a proper y equals mx plus b. That's right. Whenever we just have x or y in our equations of lines, that means it's either horizontal or vertical, and we just have to remember which is which. You can memorize it, but you can also just logic it out. Let's pretend this is y equals -2. Okay, so we'd go to -2 on the y-axis. Oh, this is the y-axis, sorry. Oh, but that's +2. I'll get there, don't worry. Y is greater than -2. Okay, so -2 is here, and it would go this way, right? Because no matter what the x is, y is always equal to -2. We want to test for which region? Is it above the line or is it below the line? Let's test with 0, 0 again. And so that would be, we only need to use the y, right? We don't need the x. 0 is greater than -2. That's actually true. We finally got one that's true. So our solution lies this way, above the line. Now you may be starting to see the pattern. If y is greater than the expression, it's usually toward the top of the graph, and if y is less than, it's kind of below. You'll start to get kind of an instinctive feel for these, and that's great, but remember you can always test them just to be sure that you guessed correctly. And just to deal with the other weird scenario, now we have the inequality that we're describing is now the x only version. Here we had the y only, and here we have the x only. So we're dealing with the two freak children right here. So let's draw this. This says no matter what the x happens to be, the y, I said it wrong. No matter what the y happens to be, the x will always be +3. So that means it's a vertical line, okay? People who like to memorize things probably memorize that y is a horizontal line and x is a vertical. That's cool, but I agree with John that you should never worry about memorizing something that you can easily logic out in a quick series of thoughts. So I don't bother to memorize which of these is horizontal or vertical because I know I can figure it out really fast. Okay, and this time we could use the origin again for the test, but this time just to be different, let me pick a random number just so you can see that it doesn't make it any harder, or it makes it a little bit harder to use different numbers sometimes depending on your equation, but it'll still work. So I'm going to pick the point 40 as my test point. Okay, so here's the actual test. I'm going to plug in 4 for the x. I don't need the y. 4 is less than 3. Is that true or false? That is incredibly false. So that means my test point is not part of the solution. So that means the solution goes this way. Oh, and I just made a mistake. I'll tell you what it is after I finish drawing these lines that look like a backwards flag to me. I should not have drawn a solid line here. I should have drawn a dashy, right? So what I do if I screw it up is just go over it again. And if I were on a test and I had accidentally drawn the solid line, I would do this, and then I would do this. I would write dash so that it was very clear to anyone looking at it that I didn't mean for that to be a solid line. So don't erase, that just makes a big mess. But fix your work and clarify your intentions. Okay, that's the end of lesson 115. It's kind of fun, don't you think? It's kind of cute. Okay, see you next time, bye.